Okay, guys, back with video 2 from 5.3. In this video, we're just going to go through these properties, conjectures about kites. Okay, and yeah, the book's got some pictures. If you want, what I did is I just did a search for Wikipedia kite properties and can do a jump down to these basic properties. Okay, but we'll go through what the book has and write them up because that's what we want to stay consistent with. So, first thing, kite angles conjecture. The blip angles of a kite are blip. All right, if we go back to this picture, we're not going to investigate that, but it's pretty clear, I think, to see that the vertex angles are not congruent. Okay, however, the non-vertex angles will be. All right, and the way we could do that is we could draw this line here, and we could say these two sides are the same. These two sides are the same. This side is a third shared side, right? So we have side congruence, and therefore we've got two congruent triangles, therefore these angles are equal. Okay, so that's our first one, and we'll write it up. Kite angles conjecture. Let me get to the right thing here. All right, so I'm just going to create a section called properties. Properties of kites. Properties. I'm going to call it the KAC, kite angles conjecture. I think that's what it's called. Yep. So this says the non-vertex angles of a kite are congruent. Okay? Again, the way that we can get that is by constructing this diagonal and using side-side congruency conjecture to get to congruent triangles. All right. Second one, kite diagonals conjecture. The diagonals of a kite are, well, they actually end up being orthogonal, perpendicular, right? You can see that right here. Okay, so we're not going to prove that one yet, but we'll just write that down as a nice property. KDC, kite diagonals conjecture. KDC, the diagonals of a kite are perpendicular. Could say orthogonal, right? It means the same thing, but perpendicular. Nice result. Whenever we draw those diagonals, they meet at a 90-degree angle. Okay, kite diagonal bisector conjecture. The diagonal connecting the vertex angles of the kite is the blip of the other diagonal. Okay, so, well, we know they meet at right angles, okay? But maybe I'll use this picture. This diagonal here, right, actually bisects this diagonal, okay? So the diagonal connecting the vertex angles, which are these, right, it's going to be the perpendicular bisector of the other diagonal. This says bisector. Maybe it's better for us to say perpendicular bisector. So KDBC. KDBC. The diagonal connecting the vertex angles perpendicularly bisects the diagonal connecting the non-vertex angles. Okay. And actually what happens, right, kind of see, well, we know that these are congruent, right? We know that this is congruent because it's itself, right? So we got those two. We know that this is 90 degrees, right? So basically, we can apply the Pythagorean theorem and say that this squared plus this, this squared minus this squared has to equal this squared, right? It's 90-degree angle. There's only, we can use Pythagorean theorem. And then if this side and this side are the same, then these two side lengths have to be the same. There's only one way Pythagorean theorem can work. Okay, so we actually prove this using Pythagorean theorem and knowing that these diagonals meet a 90-degree angle. Okay, last one, kite angle bisector conjecture. The blip angles of a kite are blip by a blip. Yikes. Well, the idea here is it's the vertex angles, right? They're bisected by that diagonal. Here it doesn't happen, okay, because this right triangle and this left triangle are not congruent, right? But the vertex angles, right, this diagonal actually bisects them because we have two congruent triangles here and two congruent triangles here. So the KABC says that the vertex angles of a kite are bisected by a diagonal. All right, let's write that up, and then I believe that's it for the properties. Yep, we'll make one more video just to keep them short on trapezoid properties. So let's write out the KABC now. KABC, the vertex angles of a kite are bisected by I'm going to say the corresponding diagonal. Okay, so again, these non-vertex angles, yeah, this actually isn't the best example, shocker, because I hand drew it, but these angles don't always get bisected by their diagonal, but these, the vertex angles, have to. Okay. All right, so that's it for kite properties. Lots of stuff there. I'm going to cut this video and then we'll talk about trapezoids.